So if you're looking at the American breadbasket in 2026, it's not just going through a typical drought. I mean, it is undergoing this catastrophic structural dehydration. And the crazy part is, our maps are literally hiding this from us.
Right, they absolutely are.
Because, you open up an atlas or you check a GPS on your phone and you see this blue line, right, just snaking across the state.
And your brain just automatically categorizes it.
Exactly. You think, okay, there is the river. It's contained. It's this known manageable quantity. We've basically built our entire understanding of the world on, like, the comfort of those neat little colored polygons and static lines.
Which is incredibly dangerous.
Yeah. And that's why today we're taking a deep dive into this really striking set of excerpts. The text is called The Chug of Water, Rebuilding the Continental Hydrologic Circuit. And our mission for this deep dive is to completely tear down that cartographic illusion.
We really need to.
We're going to explore how looking at flat maps has essentially blinded us to the reality of water. We need to start seeing it as this living, three-dimensional, interconnected energy field. Okay, let's unpack this, because the author makes a pretty bold claim right out of the gate, right?
Yeah, the author comes right out with a direct accusation. They say, a flat map lies by simplification.
Which sounds harsh, but, I mean, I get it.
Right, because obviously a map is a necessary tool. We need symbols to navigate the world. But the danger happens when a society starts to mistake that simplified symbol for the complex reality it represents.
Yeah.
Like when you see a drought map on the evening news.
Oh, with the terrifying colors.
Exactly. Those patches of yellow for abnormally dry or
Right.
the dark red for exceptional drought. When you look at that, you are just looking at a two-dimensional skin. It's a surface reading.
It's basically a weather radar for dry dirt.
That's a perfect way to put it, actually.
Because it tells you what's happening at the absolute top layer of the Earth, but it just completely ignores the volume underneath. The text argues that the real body of water is, it's curved, it's layered, it's pressurized.
And it's gravitational and electromagnetic?
Right. Like, the Platte River isn't just a surface stream, and the Ogawa Aquifer isn't just this, separate giant underground storage tank. They are expressions of a single, unified hydrologic field.
Yeah, they aren't isolated at all.
It's like looking at a flat map of a river. It's basically like looking at a 2D line on an EKG monitor and thinking that line is the heart.
Oh, that's a great analogy.
Right. You're completely ignoring the actual 3D beating pressurized muscle that's pumping blood to the whole body. You're mistaking the flat trace of its activity for the organ itself.
Which is exactly why the text introduces this new concept to break us out of that flat map thinking. It uses an ancient word, actually. The Hebrew word chug, spelled C-H-U, circumflex G.
Right, chug.
Historically, it translates to things like circle, circuit, compass, or vault, even horizon. But the author reappropriates this term for hydrology.
Okay.
So the chug is not just a ring drawn on a piece of paper. It represents a bounded relational field.
A bounded relational field. So we're not talking about a shape here. We're talking about a continuous engine.
Exactly. It's an engine.
Like water moves from the sky into the mountain snowpack.
Right. And then that snowpack melts.
It becomes the headwaters of a river. The river flows into a man-made reservoir. The reservoir feeds a concrete canal.
The canal bleeds into the soil.
Right, and the soil percolates down into the aquifer. And then the aquifer actually builds pressure and pushes base flow back up into a prairie stream.
Which feeds the crops.
And the crops transpire the moisture back into the atmosphere. The atmosphere gathers it into a storm, and the storm breaks over the land again. It's this massive loop.
And what's fascinating here is that this engine completely redefines our definition of a drought.
How so?
Well, we're conditioned to think of a drought as, simply a period where it doesn't rain.
Less water falling from the sky.
Right. But basic physics, matter cannot be destroyed. The water hasn't just vanished from the universe. What's actually happened is that the local circuit, this specific chug, has failed to close.
Oh, I see.
The regional geographic body is running a massive deficit because it's not getting back what it spent. It's bleeding energy and mass to other systems like maybe the ocean or a different atmospheric current, but it's not being recharged.
So if we accept that the map is lying to us and water is this massive 3D moving circuit, the author takes us into the physics of matter itself to measure it. And I have to say, reading this part of the source material was kind of jarring.
It's definitely a paradigm shift.
Yeah, because it brings up this principle of field before object. It argues that matter isn't just dead blocks. Like even a hydrogen atom isn't a solid marble with a tiny bead orbiting it.
Right, we really have to shed that middle school Bohr model of the atom.
The solar system one.
Exactly. Hydrogen is a nucleus surrounded by an electron probability cloud. It's field structured. And the text explores how photons are excitations of the electromagnetic field, and it even touches on the Planck boundary where quantum action and gravity intersect.
Okay, wait, hold on. I need to stop us right here.
Sure.
You just jumped from a dry riverbed in Nebraska to the Planck boundary and probability clouds.
I know, it's a leap.
It's a huge leap. The text brings up this thing called the Gertzenstein mechanism. Aren't we just talking about a river? Why is the author taking us into literal quantum physics to explain a drought? It feels a little like, I don't know, burying us in theoretical jargon to make a simple agricultural problem sound mystical.
I get that criticism, I really do. It sounds like a massive stretch.
Yeah.
But the author is doing this to establish a foundational physical truth about reality. They want to break our habit of categorizing nature into these separate dead boxes.
Okay, so how does this Gertzenstein thing do that?
Well, the Gertzenstein mechanism is a specific phenomenon in physics where, under really intense magnetic field conditions, electromagnetic waves can actually couple into gravitational waves.
But in a human laboratory, that coupling is incredibly weak, right?
Oh, so weak it barely registers. You'd need specialized equipment just to hint at it.
So why does it matter to an aquifer in the Midwest?
Because of scale and continuity. The author isn't claiming that the Platte River is literally being driven by high-energy Gertzenstein conversion.
Okay.
They're using the mechanism as a bridge principle. If electromagnetism and gravity can couple at fundamental levels, it proves they aren't sealed off, totally separate kingdoms. They belong to the exact same energetic universe. Light carries energy and momentum, which participates in the curvature of space-time. So reality isn't just a collection of isolated forces.
Okay, that makes more sense. The author is basically setting up a universal grammar for how energy moves. The text outlines this progression. I think it's brilliant. It says, field creates gradient. Gradient creates motion. Motion creates structure. Structure stores energy. And stored energy feeds back into flow.
Yes. And now apply that grammar to water.
Right.
Water is a polar molecule. It has a slight positive charge on one end and a slight negative charge on the other.
Like a tiny magnet.
Exactly. Because of this polarity, its molecular behavior is governed entirely by electromagnetism. This is why water beads up on your windshield.
Or why it coheres to itself.
Right, and adheres to soil particles. When water wicks upward through the microscopic pores of underground rock, literally defying gravity through capillary action, that is an electromagnetic phenomenon.
But when that same water eventually bubbles up to the surface and flows downhill over a waterfall, that is gravity taking over.
Precisely.
So the text is forcing us to see that the wicking of the aquifer and the crashing of the waterfall aren't two completely different things happening to a dead object. They're just expressions of a single unified energy field interacting with the Earth's mass.
The porosity of the rock, the steepness of the mountain, the heat of the sun, they all dictate how this polar mass navigates the gradients.
Right.
Once you understand water as an energetic field navigating gradients, the idea of just drawing a flat blue line on a piece of paper to represent it.
It seems almost absurdly primitive.
It really does.
Okay, so if the flat map is obsolete, how do we actually measure this field? Because the text proposes something called an interior field logic.
Yes, and it specifically challenges standard geometry to do this.
Right, it takes the shape of an octahedron. So, for you listening, imagine two pyramids attached to their square bases, like an 8-sided die from a board game.
A standard geometric measurement just counts the outside of that shape. 8 flat faces, 6 pointed vertices, and 12 connecting edges. The 8-6-12 model.
And the author calls that a shell count. Right?
Yeah, a shell count.
Huh.
It measures the absolute outside boundary of an object. But the text argues that an absolute outside doesn't actually exist anywhere in the physical universe.
Because every outside is merely the inside of a larger field.
Exactly. The boundary of a river is just the inside of the atmospheric boundary.
Here's where it gets really interesting. This totally reminds me of looking at a house from the street.
Oh, go on.
Like, you stand on the sidewalk, and you count the 4 exterior walls, you count the windows, you look at the angles of the roof. That is your 8-6-12 shell count.
Right.
But measuring those exterior surfaces completely misses the actual definition of a house.
Yeah.
A house is defined by the invisible, empty, habitable volume inside those walls.
That's spot on.
You cannot understand the purpose or the structure of the house without understanding that invisible interior center. That center is what makes it a home, rather than just a solid, unusable block of wood.
The exterior boundary only possesses meaning because there is a within.
Right.
So the author introduces this 9-7-13 geometry.
Walk us through that.
You take the 8 outer faces and you add the source face, giving you 9. You take the 6 outer vertices, add the center vertex, giving you 7. And you take the 12 visible outer edges and add the hidden inner edge, giving you 13.
Okay, but a mathematician is probably going to argue that the center of an octahedron is just a point in empty coordinate space. It's not a physical 13th edge.
Sure.
So what does that hidden inner edge actually represent in physical hydrology?
Well, in this field count category, the center isn't another physical channel made of rock or water. It represents the internal relational condition.
A pressure gradient.
Exactly. In hydrology, the aquifer is the hidden interior volume. The river you can see flowing on the surface is just the exposed outer edge.
And the reservoir is a regulating node.
Right. The pressure gradient that pushes the underground water up to support the surface river, that invisible structural integrity that is the 13th edge, the outer edges only exist because the inner pressure sustains them.
So when we look at a drought, we aren't just seeing a dry surface.
No, you are witnessing the visible collapse of inner pressure showing at the outer edge. When the Platte River slows to a trickle or dries up completely in the summer, you aren't just seeing a localized surface anomaly. You are looking at the shell face of a massive, hidden, volumetric failure happening deep underground.
The internal 13th edge has lost its structural integrity.
Exactly.
Okay, let's take this theoretical geometry and drop it directly onto the American West. Let's look at the actual geographic body the text analyzes. The Platte River and the High Plains Aquifer System.
It's a massive system.
It really is. So just geographically, we have the North Platte and the South Platte rivers originating in the high elevations of Colorado. The North Platte loops up through Wyoming before cutting east into Nebraska.
And the South Platte flows straight into Nebraska.
Right. They merge, they flow east across the state, dump into the Missouri River, which feeds the Mississippi, and eventually that all washes out into the Gulf of Mexico.
But while those rivers are making that journey, they're continuously exchanging mass with the environment.
Right. They aren't just in a vacuum.
No, they're interacting with irrigation canals, municipal intakes, agricultural soil moisture, and most critically, the Ogallala Aquifer.
And the Ogallala is this vast, porous mineral body of subterranean gravel and sand, right?
Yes. It holds water beneath parts of 8 different states: Colorado, Kansas, Nebraska, New Mexico, Oklahoma, South Dakota, Texas, and Wyoming.
Now, the text pulls some pretty terrifying data from the United States Geological Survey regarding this interior volume.
It's staggering.
It says from pre-development, which basically means before we started dropping industrial pumps into the ground up to 2019, the High Plains Aquifer experienced an area-weighted average water level decline of 16.5 feet.
That is a massive drop across a huge area.
And in terms of volume, that translates to a loss of 286.4 million acre-feet of recoverable water.
Just to contextualize that, an acre-foot is the volume of water required to cover 1 acre of land to a depth of 1 foot.
Which is roughly 326,000 gallons.
Right, so when you multiply 326,000 gallons by 286.4 million, you are looking at an incomprehensible hemorrhage of the internal volume.
We have basically drained a massive inland sea.
We really have.
And the text points to Nebraska as the critical location in this collapsing system. It literally calls Nebraska the hinge.
Yes, the hinge of the whole northern body.
But wait, why Nebraska? I mean, if the aquifer sits under 8 massive states, and places like the Texas Panhandle are famously running out of water right now, why does the author put so much intense focus on this one specific latitude?
Well, Texas is undeniably facing a groundwater crisis, no question. But if we connect this to the bigger picture, the relational circuit, the Chug Nebraska serves a totally unique structural role for the northern half of the body.
Okay, how so?
Nebraska contains the sandhills, which act as this massive, highly permeable sponge. It contains the convergence of the Platte Rivers, and it holds Lake McConaughey, which is the primary surface regulating node.
So it's the physical interface.
Exactly. The author terms it the mouth-head interface. It's the geographic zone where the buried interior volume of the aquifer and the visible exterior edge of the surface rivers communicate most intensely. The surface rivers rely on base flow from the aquifer to keep running during the dry months, and the aquifer relies on seepage from the rivers and canals to recharge.
So if the Nebraska hinge fails,
the communication between the surface and the deep interior of the entire northern system breaks down.
Okay, so the stage is set. We have an engineered system that has already lost hundreds of millions of acre-feet of its internal pressure.
Right.
We have a critical hinge in Nebraska where surface and groundwater are intimately linked. Now, we apply the 2026 drought to this fragile geometry, and the text doesn't just describe 2026 as a bad agricultural year,
No, it calls it an anatomy of a compound failure.
a compound failure. The statistics from the winter of 2025 into 2026 really illustrate a system that is just suffocating from multiple angles.
It's a perfect storm, or a lack of a storm, really.
Right. Between December 2025 and February 2026, Nebraska experienced its second warmest winter on record.
The average high temperatures broke historical maximums.
And concurrently, it was the fourth driest winter on record. Large portions of central and western Nebraska received less than half an inch of precipitation over 3 whole months.
A baking hot, bone-dry winter. But the real structural damage was happening upstream in the Rocky Mountains.
Because the mountain snowpack is the frozen water tower that charges the entire system through the spring and summer melt.
Exactly. And in March 2026, the Nebraska State Climate Office reported that the North Platte Basin's snowwater equivalent had no modern analog.
No modern analog. That's terrifying.
It's the scientific community's way of saying the historical charts are no longer sufficient to describe the collapse.
Because the storm tracks that typically deliver heavy winter precipitation to the Rockies had been displaced far to the north.
Right, and combined with that unprecedented winter heat, what little snow did fall began melting and sublimating long before the agricultural growing season actually required it.
The frozen charge of the system was spent prematurely.
Yes, which directly impacts the regulating node, Lake McConomy.
Right, the text cites UNL CropWatch data showing the reservoir entered the 2026 season at just 51% capacity.
That's nearly 30 percentage points below its historical typical level for that time of year.
Which goes back to the engine analogy. The mountain snowpack is the charger, Lake McConomy is the battery. And in 2026, you're heading into peak summer heat with a missing charger, a battery that is already half dead.
And the regional footprint of this failure is just immense. Grout.gov data indicates 93.9% of Nebraska, 96.2% of Colorado, and 98.2% of Wyoming were simultaneously in drought conditions.
Wow.
Colorado, the source of the headwaters, endured its 6th driest January through April. Wyoming saw its 4th driest.
So the drought is sitting across the source, the transit corridor, and the receiving basin at the exact same time. It's a total system clampdown.
A complete whole-body failure in the chug.
But, every time numbers like this are released, there's this immediate cultural reflex to downplay them. People point to history. They say, well, we survived the Dust Bowl. We survived the drought of 2012. Dry years happen.
Right, it's a very common defense mechanism.
But the author insists we can't just look at the lack of rain.
Yeah.
We have to look at the mechanism of the drought.
Exactly. The author meticulously unpacks the mechanics of historical droughts to demonstrate why 2026 is fundamentally more dangerous.
They start with 1934, right? The absolute nadir of the Dust Bowl.
Yes. NASA paleoclimatology data, which are reconstructions of the last 1,000 years of climate, confirms that 1934 was the driest and most widespread drought of the millennium in North America.
Of the millennium.
It covered over 71% of Western North America and was 30% more severe than the next worst year.
See, on paper, 1934 sounds far worse than 2026.
Well, it was the strongest atmospheric and topsoil drought. A winter high-pressure ridge basically deflected all the wet weather systems. But the NASA analysis points to a critical secondary cause, human land management.
Right, the plowing.
We had systematically eradicated the deep-rooted native prairie grasses and plowed the land for wheat. So when the crops failed, the topsoil was completely exposed.
The living skin of the earth was just ripped off.
And this created a devastating dust feedback loop. The massive dust clouds lifted into the atmosphere and physically reflected solar radiation back into space.
Oh, wow.
This blocked the sun from heating the surface, which inhibited the evaporation necessary to form rain clouds over the continent. NASA concluded this human-caused dust feedback was necessary to explain the extreme, anomalous severity of the 1934 drought.
So the author categorizes 1934 as a surface skin catastrophe.
Right.
So what does this all mean when we compare it to today? If 1934 was technically drier and caused this literal 1,000-year dust catastrophe, Why is the author so alarmed by 2026?
This raises an important question about the baseline condition of the water body. In 1934, the High Plains Aquifer was essentially intact.
Oh.
The deep interior volume was at pre-development levels, the surface rivers weren't mediated by massive engineered dams, and the widespread use of center-pivot groundwater irrigation hadn't really begun yet.
So the surface was obliterated, but the deep internal battery was fully charged.
Exactly.
It's like the 1934 system was a healthy 20-year-old athlete who suffered horrific, massive surface burns. The exterior damage was catastrophic, but their internal organs were perfectly healthy, giving them the resilience to eventually heal.
That's a very vivid way to put it.
But the 2026 system is an 80-year-old patient with emphysema and a failing heart. The baseline resilience is just gone.
Precisely. And the author compares this to more recent events, too, like the drought from 2004 to 2006.
What happened then?
In that period, Lake McConney hit historic lows, but the Central Nebraska Public Power and Irrigation District noted that the declining inflows to the lake were heavily influenced by upstream groundwater pumping,
Right.
and new conservation practices were actually trapping water before it ever reached the river.
So it wasn't just a lack of precipitation falling from the sky. The water was being pulled out of the invisible interior edge before it could even manifest on the surface.
Yes. The author classifies 2004 to 2006 as a managed storage drought geometry. It was a crisis of water rights, inflows, and allocations inside a heavily manipulated basin.
Got it.
Then you have the 2012 drought, which the text categorizes as a flash drought geometry.
Wait, how does a drought flash? Like a flash flood?
Kind of. The National Weather Service tracked a persistent upper-level high-pressure ridge that parked over the Rockies and the Great Plains in June and July of 2012.
Oh.
It brought high temperatures, high winds, and intense solar radiation that caused evapotranspiration rates to just skyrocket. It acted like a giant atmospheric sponge, rapidly pulling moisture out of the landscape over a very short period.
But crucially, 2012 didn't begin with a total snowpack failure.
Right, it was a rapid, late-season atmospheric clampdown.
Okay, so let's review. We have 1934, the surface skin topsoil feedback loop. We have 2004, the managed storage pumping deficit. We have 2012, the high-pressure flash drought,
And then we arrive back at 2026.
which the author calls a stacked geometry.
Because it is. We have a record warm winter, a catastrophic failure of the mountain snowpack charge, depleted surface storage in the regulating nodes, and a multi-state atmospheric drought across the entire transit corridor.
And it is all happening on top of an aquifer baseline that has already been drained by nearly 300 million acre-feet.
The stacking of these deficits creates a condition the author terms structural dehydration.
Structural dehydration.
Yes, and this is how they dismantle the first common rebuttal you always hear from skeptics. Droughts are just a natural cycle.
Right, you hear that constantly.
A drought is indeed a natural weather event, but structural dehydration is a systemic condition. When a natural drought strikes a system that has been stripped of its interior volume and its buffering capacity, the system loses the ability to weather the cycle.
Another rebuttal you hear all the time, especially if you live in Nebraska, is that the Ogallala is massive. People say, we have an ocean of water beneath us. We are fine.
Largeness is not immunity.
Right.
The author points out the basic physics of a battery. A massive battery can still discharge significantly faster than it recharges. The fact that water still exists deep underground isn't a comfort. It's actually a terrifying reality that the final reserves are being drafted to keep the surface edge alive.
Because when the internal pressure drops too low, it doesn't matter if there's still water trapped deep in the bedrock.
Exactly. The surface rivers will stop flowing and the wells will pull dry air. The pressure gradient is gone.
Which brings up the most heavily leaned upon policy solution in the modern era: conservation.
Ah, yes.
Precision agriculture, drop nozzle irrigation, municipal wiring restrictions, doing more with less.
And the author is uncompromising on this point. Conservation is absolutely necessary to slow the bleeding, yes. But conservation is not restoration.
It doesn't fix the problem.
No, using 10% less water from a dying aquifer doesn't miraculously put new water into the chug. It simply extends the timeline of depletion by a few years.
Just a slightly slower death.
Right. If the circuit is failing to close, the only mathematical way to save the system is to physically return water to the interior volume.
And this leads to the grand, incredibly ambitious conclusion of the text. Because the author states that American engineering has been exclusively focused on extraction. We built millions of miles of pipes, canals, and pumps to pull water out of the interior continent, to grow crops and build cities. but we built absolutely zero infrastructure to put net new water back into the system.
None.
To prevent the functional aridification of the breadbasket, the author proposes a continental-scale return architecture, a massive aqueduct to the aquifer.
Moving desalinated ocean water from the coasts or the Gulf of Mexico deep into the American interior.
Okay, I have to challenge the logistics of this.
I thought you might.
Because we're talking about taking water from sea level, purifying it, and pumping it uphill for hundreds or even thousands of miles to elevations of 2,000 or 3,000 feet in the high plains.
Yes, we are.
The amount of energy required for reverse osmosis desalination alone is staggering. Add the energy required for massive pumping stations to fight gravity over that distance. This sounds like an impossibly expensive science fiction megaproject. Are we actually expected to build a pipeline from the Gulf of Mexico to Nebraska?
The author addresses this exact skepticism by forcing a comparison of costs. Yes, the capital and energy costs of a continental desalination and aqueduct system would be monumental. It would require dedicated nuclear or massive renewable energy grids just to power the pumps and reverse osmosis plants.
Right.
But what is the cost of losing the American breadbasket?
Oh.
What is the geopolitical and economic cost when the center of the North American continent loses the hydrologic capacity to grow food?
Well, the cost is the complete collapse of the food supply in the economy.
Exactly. We have to look at what we've already built. We've engineered millions of miles of interstate highways. We've constructed massive continent-spanning oil and natural gas pipelines. Moving a vital liquid resource across thousands of miles is not science fiction. It is basic, established infrastructure logic. The Romans built aqueducts to sustain cities. The author argues we must build an aqueduct to sustain a continent.
But the text is very specific about where this water comes from. You can't just set up a treatment plant in a landlocked state and purify the deep, salty, brackish groundwater that is already there.
Right. Inland brackish water treatment is a localized municipal solution, but from the perspective of the Chug, it's a zero-sum game.
You're just exploiting a different layer of the same bounded field.
Exactly. True return architecture requires importing new mass from an effectively limitless source, the ocean, and introducing it into the dehydrated interior. The author's rallying cry is, aqueduct to the aquifer, not merely aqueduct to the faucet.
Awkward to the aquifer. So this wouldn't just be a pipe feeding a city's water tower so people can take showers and flush toilets.
No, a massive percentage of this imported water would be dedicated to healing the hidden 13th edge.
The internal pressure.
Yes. The infrastructure would include engineered midpoint recharge basins. These are large, designated floodplains where purified water is allowed to pool and slowly percolate down through the soil.
And what about directly into the rock?
Where geology permits, deep injection wells would actively pump the water back into the porous rock of the Ogallala, deliberately restoring the internal pressure gradient.
So by refilling the invisible volume underneath the map, you rebuild the pressure. That pressure pushes out, restoring the base flow to the surface rivers, refilling the reservoirs, and closing the broken circuit.
You transition the water from a mined resource back into a living, functioning chug.
We have spent decades engineering ways to empty the center of the country.
Yes, we have.
The 2026 crisis is essentially the mathematical bill coming due for that extraction. The only way forward is to engineer a way to fill it back up.
That's the only logical conclusion.
We have covered immense, difficult ground today. We started by realizing that the comforting blue lines on our flat maps are a dangerous simplification. We explored how the atomic structure of matter and the physical bridge between electromagnetism and gravity prove that water is a highly sensitive, interconnected energy field. Right. We learned the 9-7-13 geometry, recognizing that the visible river is just the exposed edge of a hidden, pressurized interior volume. We dissected the 2026 compound failure, how a hot winter, a vanished snowpack, and a depleted baseline created a structural dehydration far more insidious than the Dust Bowl of 1934.
Stack geometry.
And finally, we confronted the monumental physical necessity of building a continental aqueduct to actively return water to the exhausted aquifer.
It really is a roadmap from extraction to circulation. But as we conclude, I want to leave everyone listening with a thought regarding the cultural shift this requires.
Because it's not just about building pipes.
No, we can theorize about the physical engineering of desalination plants, pipelines, and injection wells all day. The deeper challenge is the cultural engineering.
How so?
Well, if water is truly a chug-bounded relational circuit where the hidden underground center is the structural foundation of everything we see on the surface, then a society that organizes its entire economic philosophy around endless extraction is fundamentally at war with reality. An economy based on drawing down an ancient aquifer to maximize short-term surface yields is incompatible with physics. So the question is, are we capable of evolving our political and economic systems to value the invisible, underground volume of the map just as much as we value the visible, profitable crops it produces on the surface?
Can we build a society that values the return of water as much as the taking of it?
Exactly. Or will we stubbornly cling to the illusion of the flat map, pumping the last drops of the internal edge until the rivers vanish, the wells run dry, and the dust storms return to bury the breadbasket?
A society at war with reality. That is the true stakes of 2026. I want to thank you all for joining us on this deep dive. I highly encourage you the next time you pour yourself a glass of water to really look at it differently. Don't see it as a static object isolated in a glass. Recognize it for what it is, a tiny momentary pause in a massive living continental circuit. Until next time.